And it's my pleasure to introduce Amy Jian, talking about what's new with Atlas Search. Please give her a round of applause.
Hey everyone, how's it going? Welcome to New York if you are not from the area. I hope we've all enjoyed some of the talks that we've had today. I know I have, and hopefully this one lives up to your expectations too. My name's Amy, and I'm a product manager here at MongoDB. For the last 10 months, I've been working with the Atlas Search team, and let me tell you, we have so much exciting new stuff delivering this year, and I'm so excited to finally be able to share it with you all today. We've waited long enough, so let's not wait any longer. This is what's new in Atlas Search for 7.0. In today's session, I'm going to spend a few minutes talking about a brief 101 overview of what Atlas Search is and how it can be used for those who aren't already familiar. Then, I'm going to get into the juicy new details of what's new in Atlas Search this year, and if you heard our keynote presentation, you might already have an idea of what search nodes, managing search indexes across the developer experience, and search query analytics are. And at the end, I'm going to wrap it up with a few closing remarks before hopefully saving a few minutes at the end for some Q&A. Let's get into it. Kicking it off with Atlas Search 101. Can I get a show of hands of who here in the audience is already using Atlas Search in their applications today? Nice. And anyone out there who's heard of Atlas Search or has tried it but not deployed into production yet? Okay. And everyone hands down, who here has never heard about Atlas Search and is probably at the wrong talk and is trying to find a way to sneakily get out of the crowd? Well, I'm going to ask you to stay in your seat, even if you are at the wrong talk, because I think you're going to regret missing this talk. So, let's get everyone on the same page. Going back to the basics, what is Atlas Search? Atlas Search is a full-text search solution built on top of Apache Lucene, which is the industry-leading open-source search engine solution. Even if you have not known it, I would guarantee that within the last week, even the last day, you have interacted with an Apache Lucene-based search experience. Apache Lucene enables you to get relevant results when the traditional database search, like an exact match, or if you're feeling fancy, a regex match, isn't giving you the results that you need. I'll get into more of what that exactly looks like in the next slide. And while there might be a number of full-text search solutions out there, Atlas Search is the only one that is made for MongoDB. It is a fully managed, seamlessly integrated into the developer ecosystem, and that makes it the #1 solution for all your full-text search needs. So, what can full-text search do that database queries can't? It is the technology that allows you to return relevant results even when you have a typo or a misspelled word. In the industry, we call this fuzzy search. So, I don't know about you all, but in the summertime, everyone and their mother is in Central Park trying to have a very aesthetic charcuterie board picnic. And for me personally, prosciutto is a very difficult word to spell. But no matter if I put the S or the C in the wrong place, or I put an extra T in there, the web app of the grocery store that I'm shopping at is still going to deliver me that beautiful, cured meat product that I'm looking for, because they have fuzzy search enabled. Or maybe I want to use synonym search. When I search white sneakers, I want results for white shoes to automatically be returned too. Full-text search also supports custom storing so that I can boost any promotional listings that I want to make sure that the buy one get one products are at the top of the result set. That's not all. That autocomplete search as you type drop-down suggestions experience that we have come to associate with basic search experiences is also powered by full-text search. Another table stakes UI feature these days is that left-hand facets and filtering feature, and this functionality is also supported by Atlas Search and Lucene. Last on the list of features that I'm calling out right now is highlighting. So when you're searching within a pretty thick document set or a description which has a lot of text and you want to know exactly which part of that text matched on your search terms, highlighting can tell you exactly that. It will split out which part of the description matched your search terms. So while that's the last of the examples that I'm giving today, it's not even everything that Atlas Search can accomplish. Did I mention you get all this at a lightning fast speed? I think that's pretty incredible. So it's pretty evident that with MongoDB Atlas and Atlas Search, you can develop apps faster, provide a better search experience for your end users, all while driving meaningful business results. Again, pretty amazing. So, now that we're all on the same page, let's get into what you're actually here for. What's new in Atlas Search this year? To kick things off, I'm going to spend a few minutes talking about architecture. This illustration illustrates what the Atlas Search architecture looks like today. We have, for example, a typical 3-node replica set with 1 primary and 2 secondaries. Each of these nodes runs both the MongoDB database process and the MongoT Atlas Search process. This is what makes it phenomenally easy to get started using Atlas Search. You don't have to provision any resources or make any changes to your configuration to be able to create a search index and immediately start leveraging the power of Lucene. But unfortunately, this also leads to the difficult task of sizing your workload to meet the needs of both your database and your search workloads. You might have a pretty light transactional workload, but a very heavy search need. This also can lead to resource contention in some of those situations where your database and search workloads are competing for the same resources. Inevitably, in some rare cases, it can also lead to database availability issues when Atlas Search is ever unavailable. At the end of the day, that does mean that you are unable to scale search independently of your database needs. But at MongoDB, it is our priority to be able to support all of our users' mission-critical applications, no matter what their requirements are, without compromising. And so that is why today I'm so excited to announce that we are supporting search nodes, the ability to provision secondary nodes dedicated only to running Atlas Search. So in this illustration, you still have your typical 3-node replica set with 1 primary and 2 secondaries, but now they only run the MongoDB database process. You have 3 additional secondary nodes dedicated only to running MongoT. So what this means is you can now scale your database process needs outside of what your search needs. You can keep your database replica set relatively low if you have a high read workload and just increase the number of nodes you need to support your search workload. So, pretty evidently, this leads to workload isolation, as I just mentioned. You can say goodbye to resource contention between your database and your search deployments. And naturally, with dedicated resources, you'll experience better performance at scale as your workload grows. And with that comes higher availability because MongoDB never has to compete with that pesky little MongoT process for resources. And I know a lot of you out there will appreciate this one too. You'll get faster search index builds now that you have secondaries dedicated to building search nodes. So for those customers who have highly scaled resource-constrained workloads, or if you're starting because of Atlas Search, dedicated search nodes is for you. And as of today, search nodes is available as a private preview early access feature. You can go to mongodb.com/DASAL, which is the name of our early access program. We like to call it Dazzle. Or you can scan this QR code here to get directly to that page. If you have an account team, you can also reach out to them directly to be nominated. Once you're accepted into the program, you will then be able to provision search nodes either through the Atlas UI or the API, wherever you prefer to manage your cluster. So in the API, when you turn on workload isolation today, there will be a new option for search nodes. You can choose from as few as 2 nodes up to 32. And then within the cluster tier options, you can also choose search tiers between S20 up to S60. In this example, I'm doing S40 and giving the name of my cluster as usual and hitting deploy. That's it. I have search nodes now, just as easy as it was before. So as of today, search nodes is only available on single region and AWS clusters. Support for sharded environments, multi-region, GCP, and Azure are in active development and are coming very soon. And if this is something that you have feedback for, I highly recommend that you join the Early Access program, because this program gives you the opportunity to influence feature design and development through regular check-ins with our product managers like myself. It also gives you access to dedicated MongoDB community forums where you'll be able to learn and start discussions with other users who are trying out the same features as you. Last but not least, Dazzle also gives you a platform to share your story, because we love to highlight our Dazzle customers on our blog and at mongodb.local events just like this one. So, if this is important to you, please, please, please go to mongodb.com/dazzle to sign up for the Search Nodes Early Access program. Because the most important part of this all is that our priority is to ensure that we are addressing your problems and delivering a better experience overall, and we can't do that without your feedback. So, another question that you might have is, can I still use traditional Atlas Search, where MongoD and MongoT run on the same node, and I don't have to do anything to spin up a search index? And the answer is yes. We are going to be supporting both architectures, and so you don't have to worry about managing your resources, even if you just want to create a search index on an existing database collection. So both architectures are suitable for development and production environments, so there isn't a decision to be made either about what you want to use for your lower environment versus production. Okay, I think we've talked a bit too much, maybe, enough about architecture. Let's move on to talking about what happens after you've set up your environments already and you need to optimize what actually happens with search. In the world of relevancy-based search, this means talking about search indexes. They are the foundation of what makes Lucene and consequently Atlas Search so powerful. And as a developer data platform, we strongly believe that users should be able to use and manage their search indexes wherever they are. And oftentimes, this means where they're already working with their database indexes. Historically, you have been able to create search index through the Atlas UI, the Atlas Admin API, and the Atlas CLI. We also support a number of integrations through Terraform and AWS CloudFormation, but we know that this is not enough for all of our users. So I am incredibly excited to announce not one, not two, but 3 brand new ways that you will be able to create, update, delete, manage your search indexes. Can I get a few shouts in the audience of where you might want to manage your search indexes? Don't be shy. Nothing? Quiet crowd today. Well, I'll give you the answer. Starting today with Mongo Shell and the Node.js driver, you will now have access to 4 brand new commands where you can create, update, delete, and manage your indexes. Support for other drivers and Compass are also coming later this year. Let's take a look at what syntax looks like in Mongo Shell. So, I can use the create search index command to create a search index by passing in a name. Here I'm using my search index and passing in a search index definition in JSON. This is just the default definition for those who aren't familiar, where dynamic is set to true. That just means that all the fields in all my documents are going to be indexed. Next, I can use update search index if I decide that I want to change something about how my documents are being indexed. All I have to do is pass in the name of my index and pass in the new index definition. Here you can notice that dynamic is now set to false, and I've decided that I want to index the description field as a string type. Later, some time goes by and I decide that I don't need this index anymore. To keep my cluster clean, all I have to do is call drop search index, pass in the name of that index that I want to delete, and boom, it's gone away. At any time during this process, I can also use the get search indexes command to get an overview of all the search indexes within my collection and see what their statuses are. I won't spend any time going over the exact syntax for every driver, but as usual, you can expect the driver syntax to be natural to that language's semantics, and if Compass is where you prefer to manage your search indexes and queries, you will be able to do that as well later this year. So, now that you can create, update, delete, manage your search indexes wherever you are in the MongoDB ecosystem, let's talk about how to achieve the next level of getting usage out of Atlas Search. Because in today's age of big data, it is critical for all applications to be leveraging data and analytical insights for business operations. For relevancy search, this means having visibility into how your end users are searching and interacting with your application. In other words, leveraging client-side data about how end users are interacting with your application to make optimizations on your search indexes and queries to deliver more relevant results and drive meaningful business results. With Search Query Analytics, you'll be now able to track search end users' text-based search queries to answer questions like, what are users searching for most frequently? In the UI, you'll now be able to see the total number of search queries which are tracked up here in the top left, approximately 13,000, and the top 10 most popularly searched for terms. So in this example, we tracked the searches that users were making on the MongoDB documentation page. You can see the top result there is find, which means that that was the most popular search within our documentation page. It was searched for approximately 150 some times, making up for approximately 1% of all searches. I can also get the same information about the top queries that return no results. So there was about 17,000 queries, 1,700, queries that return no results, which thankfully, because that's a poor user experience, only accounts for about 0.1% of all searches. I'll also be able to see the search terms that resulted in no results. The importance of all this data is that now that I have this, I know where to focus my efforts to optimize my search queries or my search indexes to make sure that I'm always delivering something relevant for my users. In the Search UI today, you'll now see a new tab for Search Query Analytics, and there'll be a very easy syntax example of the parameter you have to add to each query that you want to track. It's called tracking, and you specify what you want to track in the search terms parameter. If I run this simple query that's searching within my Airbnb app, I look for waterfront, I add in the tracking parameter to also search for, to track the waterfront term. I'm going to hit search a few more times here to mimic multiple users searching for waterfront, and then I'm also going to make a change to search for listings that have schools near them, also search a few times. And just like that, those queries are going to be tracked. When I now go to the Query Analytics tab, I can see that the most popular searches on this collection are for waterfront and school. I can dig into each of these search terms on the individual level and see the exact query that was run so that I know where in my application code base to go identify and improve those queries. You might be asking, why does this matter? Well, now that I know that my users are searching for waterfront or school, I can follow up on those and take some action to optimize those results. First, are there any promotional listings with waterfronts or schools that I should boost to the top of my results so that users have something that they're more likely to convert on at the top of their listings? Or, is there anything that I can improve about the page's navigation or the table of contents or filtering options to make it supremely easy for users to be able to find listings that say waterfront or school in them? Or maybe there's something that my marketing team can do to run a campaign to capitalize on this back-to-school interest or summer interest in waterfront listings. And finally, I might consider simply increasing my product catalog to increase the number of listings that have waterfronts or schools to make sure that every user who is looking for a waterfront or school listing has something that they can buy, which will drive business results for me. Similarly, you can also see which searches did not return any results. In the demo, I'm just searching for ASDF, which evidently does not have any results, and then I go over to Query Analytics to see that there was 4 times user searches which didn't deliver results, and again, I can dive into that ASDF search term and see the specific trends relating to that and the query that I need to go investigate within my application code to resolve this issue. So imagine this. I am an online shoe retailer and I use Atlas Search to power the search bar that my users type into to search for the shoes that they want to buy. Query analytics tells me that the most popularly searched term is basketball shoes. And I know from historical orders that LeBrons have the best conversion rate for users who land on that product page to those who ultimately put the product into their cart and check out. So what I might do now is make sure that for every search for basketball shoes, LeBrons end up at the top of those results, because that way I'll drive more people into the funnel of those users who are landing on the page for LeBrons, and that might end up in the ultimately might end up putting those shoes in their cart and checking out. That means more revenue and more business results for me. Similarly, the top no results query is Air Jordan. That's a huge bummer, because even though we don't have Air Jordans in stock right now, we do have a number of other similar Nike products that those users who are searching for Air Jordans might be interested in. So what I can do here is add a synonym for Air Jordan as Nike. So instead of returning no results when users search for Air Jordan, they're going to see a list of similar Nike products that they might be interested in, click on the products page for, and that's just another user who, instead of maybe even churning from the website because they didn't get any results that they were looking for, have the opportunity of capturing and driving more revenue for my business again. As you can see, Query Analytics unlocks the next level of driving business value with Atlas Search, all within the same easy-to-use MongoDB ecosystem that we know and love. And so the last question is, how do I get access? I'm very excited to announce that Query Analytics is now available as a public preview to all MongoDB Atlas users on version 6.3 or later, as long as you're running on an M30 tier cluster or higher. And as always with everything that we deliver, we want to hear your feedback about what you like and what you want to see next, and how we can do better to make developing modern applications with MongoDB Atlas as easy as possible. So while that wraps up all the announcements that I'm making today, that is not even all that is new in Atlas Search these days. In case you missed the keynote presentation, we just announced public preview of our vector search solution, which opens up a world of possibilities with semantic search. We also just had the amazing talk from Chris Grabowski about building intuitive data discovery experiences with Atlas Search, where he demoed our latest and greatest sorting in search functionality. You do not want to miss these, so make sure you check out the recordings on YouTube available on Monday if you haven't seen them. So, just before I open up the floor to questions, I want to quickly recap everything that we talked about today, because I know there was a lot. First, there was a refresher on what Atlas Search is and the power of Apache Lucene full-text search. Then we shared the incredible announcement of Search Nodes, which allows you now to scale your database and search needs independently. Next, we talked about search index management, where starting today with Mongo Shell and the Node.js driver, support for the other drivers and Compass coming later this year, you can now manage your search indexes wherever you are within the broader MongoDB ecosystem. Then, we talked about search query analytics and the value of leveraging data analytics to drive business results. You can now see top queries to get a sense of what's trending, what's popular, and where to focus your efforts to capitalize on user interest. Top no results queries also identifies gaps in your existing solution and where you need to go to resolve your problems. And finally, like I just mentioned, the keynote presentation announced our vector search offering, as well as Chris Grabowski's talk just now about our sorting in search functionality. So, thank you so much for attending my talk today. I will now take any questions, but if you don't have any, I will really appreciate it if you left some feedback for today's session. And if you ever have any feedback about Atlas Search, I'd highly encourage you to check out feedback.mongodb.com. That is the best place for you to get in touch with product managers. We regularly check that page to get a sense of what our users are looking for and how we can improve. Thank you so much.
Thank you so much for all that info about Atlas Search. Does anyone have any questions for Amy? I can bring you the phone.
Thank you. I got two questions. Number one is, how does the performance compare with Elasticsearch, like just on vector search functionality? Number two is like, what are the low-hanging fruit that we could like replace Elasticsearch per se? Thanks. Like use cases per se. Thanks.
Sorry, do you mind repeating the last part of your question?
Like what are some like low-hanging fruit use cases that we could just replace Elasticsearch? Like is that like on e-com website, these like shopping cart or like just search on e-com website, those are use cases we could just like replace 100%? Is that how to think about that? Thanks.
Yeah, thanks for the question. So the question was, how does Atlas Search compare to Elasticsearch, which is one of the common competitors that we see? And I will say that this is a really difficult question to answer because it all depends on a number of factors, including what your document schema looks like, what your workloads, your transactional and your search workloads look like, and how many queries you're expecting, and as well as the relevancy search needs that you have. So what kind of like pure search features you need. I will say that for a number of use cases, including ones that you listed, like e-commerce, a lot of customer 360, single view, and application search needs, those are the bread and butter of where we see a lot of Atlas Search use cases today. And so if you have more questions about that, I'd highly recommend reaching out to the Atlas Search experts. We have a few at the Ask the Experts booth today to get a better sense of how you can be successful with Atlas Search for your needs.
Hi. Like you mentioned, we have published vector search. So for the people who are using Atlas right now, or how will our DBs look like? Will we have to, if we want to search based on vector search, or will there be any features by Atlas Search where that allows us to do that with vector search and improve our DB search for that matter?
Gotcha. So I think the question is, in essence, how can you use Atlas Search with vector search?
Yeah, and right now, if my DB is in MongoDB, right, we do not have vector fields in it. So the whole migration process and then that being effective with Atlas Search, that timeline, how would that look like, or how would that process look like?
Right. So today, Atlas Search evidently is a feature of MongoDB Atlas. So you have to have your data stored in MongoDB Atlas to be able to leverage the features. And with vector search, that is the same thing. Your vectors do have to be stored in MongoDB Atlas. But that being said, we recognize that vectors are sort of a different kind of document to store, and we are actively looking into, it's not something that we have confirmed or that we have ruled out, whether we will support using vector search with other database stores. And I will say that vector search and Atlas Search, evidently vector search opens up a whole new world of possibilities with semantic search, but there are still areas where keyword search and relevancy-based search still performs better than vector search. So that is another area where we're actively researching how we can make hybrid search, which is the combination of vector and relevancy-based search, the most effective. And those are two areas that we're very actively looking into and researching to look into what the best solution that we can deliver, which aligns with the rest of the developer data platform here at MongoDB.
We have time for one more question if anyone has one. That it? All right. Thank you so much. Give one more round of applause for Amy Jian.
Thanks, everyone.